This counting of boson and fermion states can seem very abstract, as can the whole idea of identical particles in quantum mechanics. As I said, they are more identical than any two objects that we can physically make in any factory. There is, however, an analogy in our everyday world that does correspond rather well to the ideas and some of the behaviors of identical quantum mechanical particles. It's something we humans have invented and that we use every day, namely money. And in at least one sense, we can, of course, say we make it.
We're going to take a bank account analogy. Suppose that you have an antique jar in the kitchen for your spending money, and we'll call that A for antique jar. So here's the antique jar. And a box, which we'll call B, under the bed for your savings money. So here's the box you keep under your bed for your savings money. You put your dollar bills, so here's a dollar bill, and here's another one, each labeled with a unique number, so this is number 1, this is number 2, into either the antique jar or the box. This is like the quantum mechanical situation of non-identical particles, the dollar bills, and different single particle states or modes, A or B, into which they can be put, the jar or the box. If I have two dollar bills, then there are 4 possible situations. That is, 4 possible states of the entire system. And that entire system includes 2 dollar bills and the antique jar and the box, and the dollar bills are in one or other or both of those. So we could have bill 1 in the box and bill 2 in the box. That's what we've shown here. Or we could have bill 1 in the box and bill 2 in the antique jar. Or we could have bill 1 in the antique jar and bill 2 in the box. Or we could have bill 1 in the antique jar and bill 2 in the antique jar. So here are our 4 states. Here we see them in pictures. And this reproduces the counting for non-identical particles. These dollar bills are not identical. They're very similar, but they're not identical because they have different serial numbers. Consider next that you have 2 bank accounts, a checking account, which we'll call A, and a savings account we'll call B. You may still have the same amount of money, $2. You may know how much money you have in each account, but the dollars themselves are identical in the accounts. So now there are only 3 possible states: $2 in savings, $1 in savings and 1 in checking, and $2 in checking. Note that in these 3 possible states, $2 in savings, $1 in savings and 1 in checking, and $2 in checking, there are 2 states with both dollars in the same account, but only 1 in which they're in different accounts. This bank account argument gives the counting for identical boson states. Consider now that you have 2 bank accounts, a checking account, A, and a savings account, B, but you're living in a rather strange country called the Protectorate of Pauliana. And in the Protectorate of Pauliana, they have some very strange banking regulations where you may have no more than $1 in each bank account. Perhaps they had too much trouble with students and bank accounts in some earlier time. Then, for your $2, there is only 1 possible state: $1 in savings and $1 in checking. This, of course, reproduces the counting for fermion states. So, for the case of 2 identical fermions, there's only 1 possible state for our $2, with each dollar being in a different bank account. For identical bosons, there are 3 possible states for our $2, in 2 of which both are in the same bank account, and in 1 of which they're in different bank accounts. And for non-identical, that is, also classical particles, there are 4 possible states for our dollar bills, in 2 of which both are in the same bank account, and in 2 of which they're in different bank accounts.
So then, money in bank accounts behaves in many ways like identical particles in states. Identical quantum mechanical particles are as identical as dollars in bank accounts. This is quite a good way to think about identical particles. We are quite used to the idea that dollars in bank accounts are identical. The individual dollars in a bank account have no distinguishing identity at all, though the dollar bills we handed over to the bank teller could all have been different and each, hopefully, quite specifically unique with its own serial number. There is, however, only one way to have a specific number of dollars in one bank account, just as there is only one way to have a given number of photons in a mode of the electromagnetic field, for example. This is the sense in which identical quantum mechanical particles are identical.